Hello, this is Mrs. Garple, and in this video I'm going to take you through rewriting logarithmic equations into equivalent forms. Our equations are going to have expressions where we have addition, subtraction, or we're multiplying by a constant value. And we're going to use these three properties or rules of logarithms to help us with those conversions. So we have the product rule, where log base b of x times y can be written as log base b of x plus log base b of y. We have the quotient rule, log base b of x divided by y can be written as log base b of x minus log base b of y. And we have the power rule, where if we have log base b of x to the power of k, we can write it as k times the log base b of x. So let's take a look at our first examples here. Here, our first equation is a of x equals log base 10 of x plus log base 10 of 4 plus 1. Well, only the first two parts of this are written as a log base 10. So let's rewrite 1 as a log base 10 value. So we can write this as log base 10 of x plus log base 10 of 4 plus log base 10. Well, we know if the base is 10, the argument would also have to be 10 in order for the value to equal 1, because 10 to the first power is 10. Now I can apply that rule where if I have addition of logs, I must have multiplied some factors in the argument. And since all of these are connected by addition, I can write this as log base 10 of x times 4 times 10. And then I can simplify that expression, and we will have log base 10, 4 times 10 is 40, x. Let's take a look at b. With function b of x, everything is written as log base 10, so we can go ahead and use the product rule because they're all connected by addition again, and write this as log base 10 of x times 5 times 8, and then simplify so that we have log base 10 of 5 times 8 is 40 x. For example C, we've changed our base. So we've got log base 5 of 125 plus log base 5 of 25x. What we can do is we can simplify log base 5 of 125. Log base 5 of 125 is going to be 3 because 5 to the third power is 125. I am going to take the time to expand log base 5 of 25 x to be log base 5 of 25 plus log base 5 of x. The reason I did this is because log base 5 of 25 gives us an exact value. 5 to the second power is 25. So I can write this as 3 plus 2, because 5 squared gives us 25, plus log base 5 of x. And then I can combine 3 plus 2 is 5 plus log base 5 of x. And I have two more, I believe, to do with you. These two are a little bit longer, have a few more operations. Looking at d of x, I have the first two added together, and then I have the last three written as a subtraction. So a couple of things. I am going to take and go ahead and just write this as log base 5 of 50. But then I'm going to expand log base 5 of 36 plus log base 5 of x. So I have a product of two factors. I can write that as an addition. With these final three, I'm going to factor out a minus 1, or just a minus. Because what that's going to give me is a positive log base 5 of 4 plus log base 5 of 3 plus log base 5 of 2. So now we have some other ways we can simplify some things here. I guess I didn't really need to change this to a plus log base 5 of x. It's okay that I did. What I'm noticing is since all of these have a plus, I could just look at this as being log base 5 of 50 times 36 times x subtract log of 4 times 3 times 2. Oops, that's log base 5, excuse me. Got to keep that base. So now that I have this written as a subtraction of two logs, I can use that quotient rule and write this as log base 5 of 50 times 36 times x over 4 times 3 times 2. The reason I didn't go ahead and multiply things is because I'm going to try to simplify within this as much as I can right now. So 4 times 3 is 12, and I could cancel the 4 times 3 being 12 with the 36, leaving me 3 in that numerator. 2 will go into 50 25 times. So now I will have log base 5 of 75x. But if I go back and I look at what I had previously, the 25 times 3 times x, and I know that my base is 5, and I know 25 is a power of 5, I could just actually leave this as, or write this as, because I have a product, log base 5 of 25 added to log base 5 of 3x. Again, we know that the value of log base 5 of 25 is going to be 2, because 5 to the second power. is 25 added to log base 5 of 3x. And then our last function. We have, I'm going to use a different color for this one, log base 5 of 9x minus log base 5 of 3 plus log base 5 of the square root of 625 plus log base 5 of 1. The subtraction tells me that I could be writing this as a quotient, log base 5 of 9x over 3 added to log base 5, and let's see if 625 is a perfect square. So the square root of 625 is 25. So we have log base 5 of 25 added to log base 5 of 1. Well, the power of 5 that equals 1 is 0. So log base 5 of 1 is 0. So we're going to end up looking like we're not adding anything on the end there. And we have log base 5, 9x divided by 3 is 3x, plus, as we noticed in the previous problem, log base 5 of 25 is 2. So we actually have 1, 2, 3 equivalent expressions happening here that are all equivalent to log base 5 of 3x plus 2. And this concludes the video on using properties of logarithms in order to rewrite equivalent equations.